Alright, and welcome to segments formed by secants and tangents, level 5. Now, in this very first example, we notice that we have a tangent right here, this line CD, and we also have a secant right here. Now let me kind of switch to just a nice red or a UT burnt orange color. Now let's review our rules for secants. We know that secant is always the outside segment times the whole thing. Now, in this case, we know what the outside segment is, so let me just go ahead and write that there. It'll be 7 times. However, this is where these kind of get a little bit tricky. When we're talking about the whole thing, what we really have is this. We have 7, the outside piece, plus the inside piece, which is x plus 5. Now notice, what are my like terms? What can I combine? I know 7 is a constant. I see 5 is a constant. And so when I go to put this together, I see that, okay, I can do 7 plus 5, which would give me x plus 12, close parentheses. Okay, now just kind of switching back to this nice teal color. Once again, our tangent is CD. And so we'll say, okay, equals 9. And ask yourself, what do we always do the tangent? Well, of course, we square it. Okay, so working on down through this, we know that we'll simply do 7 times x, which will give us 7x, 7 times 12, which will be 84, is equal to, and what is 9 squared? Well, of course, 9 squared would be 81. Alright, just moving on through this. What should we get rid of next? Should we get rid of the 7, or should we get rid of the 84? Well, in this case, we know we want to get rid of our constant first. So minus 84, minus 84. And working down, we now have this. 7x is equal to 81 minus 84, which would be negative 3. Now, how can we get rid of the 7? Well, of course, we will divide both sides by 7. And it turns out that x is equal to negative 3 divided by 7. Now, let me go ahead and grab a calculator. And let's see what this is as a decimal. Okay, so let's see. Negative 3 divided by 7 would be negative 0.43. And you might be thinking to yourself, wait a second. We can't have a negative x value. Not necessarily true. As long as our segments are not negative, then it doesn't matter whether x is positive. So let's kind of look here. When we look at this x plus 5, this line segment EB, well, if we were to do negative 0.43 plus 5, it will still be positive. So it is absolutely okay to have a negative value here. Now, the question is actually asking us to find the length of CB. And we know that CB, this whole thing, was actually this expression that we first wrote. And so we can just simply write, right here, we know that the whole segment was x plus 12, which was equal to the length of CB. And in this case, our x value is negative 0.43 plus 12, which is equal to CB. And let me go ahead and grab my calculator. And when I look at that original thing and I add 12 to our x value, it turns out the length of CB will actually equal 11.57. And in this case, 11.57 inches. Alright, go ahead, pause this video, write down whatever notes you were unable to take, and then let's move on to example 2. Okay, and here we have example 2. And this has a word problem with a diagram, so let's fill in our information as we read through it. So it says, find the length of CB when given that CE is 6, so we can label CE as 6 inches, and EB, so let's see, so I see EB is right there, is 3x plus 5 inches, of course, and we're also given that CD is, once again, 9 inches, kind of convenient. Now, when I look at this, okay, so we want to go ahead and first take a look at the secant, and if you'll recall, our secant will always be the outside piece, which is 6 times the entire thing, which in this case would be 3x plus 5 plus So the inside plus the outside, 6. And when I look at this, I ask myself, what are my like terms? Well, in this case, we know that 5 plus 6 is going to give us 3x plus 11 equals, and of course, when you look at your tangent, we always know that our tangent will be squared. Now, let's go ahead and start working through this. And so we see that 6 times 3x will give us 18x, and 6 times 11, well, of course, that'll be 66, is equal to, and think back to our last example, what's 9 squared? Well, of course, that would be 81. Now, working through here, we just want to solve for x. So what do we get rid of first? Do we get rid of the multiplication or the addition? In this case, we know we always get rid of the addition first through subtraction. So the opposite of plus 66 was minus 66. That gives us our 0 pair. And we have 18x is equal to 81 minus 66. Now, I think it's always smart to use your calculator in this case so you don't make a mistake. And 81 minus 66 will give us 15. Okay. Now, how do we get rid of that 18? Well, when two things are being multiplied, to get rid of multiplication, we have to divide. And so, after dividing both of those, I have 15 over 18. And let's just go ahead and divide that. Let's just get our decimal, which in this case will be 0.83. Now notice, ask yourself, is that the answer to the question? In this case, no. We want to find out the length of CB. And remember, CB is that whole thing, which is kind of nice because we actually have the expression that represents the whole thing right here. It is 3x plus 11, and remember that's for CB, our entire segment. So let's go ahead and plug these things in. So we have CB is equal to 3 parentheses 0.83 close parentheses plus 11. Now here's where I would suggest, reaching for your calculator, because we know that 0.83 times 3 will give us roughly 2.5. So I'll say CB is equal to 2.5 plus 11, which gives us our final answer of CB is equal to 13.5 inches. And sorry if that got a little bit cramped. So we know our x value was 0.83, but the final answer was 13.5 inches. I hope this helps. Good luck, and take care.